An important reaction that takes place in a blast furnace during the production of iron is the formation of iron metal and carbon dioxide from iron 3 oxide and carbon monoxide. Determine the mass of iron 3 oxide required to form 910 kilograms of iron. Determine the amount of carbon dioxide that forms in this process. So, to visualize what's going on, it is best to write a chemical equation. So, iron is formed, so I know iron is my product. The formation of iron from carbon dioxide, with carbon dioxide from iron 3 oxide and carbon monoxide. So those are my two reactants here. So I'm going to start by writing iron 2 oxide plus carbon monoxide makes iron metal, which exists as a solid, and carbon dioxide gas. Alrighty, then you always have to make sure you balance. So I have 2 irons here, and then I have 4 oxygens here. So if I put, how many carbons do I have? 2, 1, 1. So I'm going to put a 3 here, and then a 3 here. So that gives me 3 carbons. Then I have 6 oxygens. So 3 plus 3, then I have 6 oxygens. Perfect. All right, so I'm given that I have 910 kilograms of iron, and I want to know 2 things. So I want to know the grams of this that was used to make 910 kilograms, and then how much mass of this is formed. So in one, I'm working backwards, and then I'm working back to forwards. Okay, so since I'm given here mass of iron, and I want mass of iron 3 oxide, I know that I will use my mole ratio. In order to use mole ratio, I need to go to moles. So I have to convert to my moles of iron using molar mass, then moles of iron 3 oxide using the mole ratio, and then back to mass using molar mass. So I created myself a little plan. Just knowing that going from one compound to another does not matter which direction, you need mole ratio. And then depending on what unit you're given in, if you're given already in moles, then you don't have to convert. But we're given here in mass, so we have to convert from one to the other. Okay, so starting with 910 kilograms of iron. My molar mass of iron, if I write it over here, is 55.85 grams per mole. Since it's in grams per mole and I'm given in kilograms, I have to convert to kilograms first. My gram to kilogram conversion is 1,000 grams over 1 kilogram. Then I can use my molar mass. Then I use my mole ratio. And then I can use my molar mass again. And that equals to 1.30 times 10 to the 6 grams. Since I was given originally in kilograms, I'm going to take one more step and go back to kilograms. And therefore, my answer is 1.30 times 10 to the 3rd kilograms of iron 3 oxide was used to make 910 kilograms of iron. So then now I want to know how much CO2 was made. So then I take my mass, my kilograms of iron 2 oxide, and I want kilograms of CO2. So I know I have to use mole ratio in there somewhere. But this time again, you first go to grams using prefix conversion, then moles of iron 2 oxide, so that you can then go to moles of O2 using mole ratio, grams of O2, CO2, and then kilograms. Now you start with your 1.30 times 10 to the third kilograms, or you can just use your 1.30 times 10 to the 6th because you already have that conversion to save yourself a step. Use the molar mass to get to moles. Then use the mole ratio. And then molar mass one more time. That gives you 1.08 times 10 to the 6 grams. Since we want to be in kilograms the whole time, then again, one last conversion from grams to kilograms, which gives you 1.08 times 10 to the third kilograms CO2. So it's just basically a stoichiometric equation, knowing that you have a mass of one of the components, and you can use the molar mass and mole ratio to find any other components in the reaction.